right, so this is going to be a little bit longer of a lesson, so try to stay with me because it is a little bit tricky. So we're going to start talking about predicting products. So again, if you're watching this live, I would just pause it and write down the things. You could also go with me and just pause before I talk about each equation, write it down, and then unpause, listen, pause again, write down the equation, unpause, listen, if you'd like to do that. Anyways, but make sure you have your paper out, write down predicting products. We're going to use this section later, the diatomic molecules, so don't worry about that right now. And write down this first equation. So you'll notice in this first equation we have K plus F2, and then we left the space blank. So on your test, there will be some where I give you the whole equation and you balance it. But there will be some where I just give you the reactants, and you're going to have to tell me the products and then balance your equation. So I might take a second and have you think about what product would you imagine would come from K and F2. Now from K and F2, you might think our products would be KF2, which is almost correct. If you're thinking this, you're on the right track. But our products are actually going to be KF. Alright, so we'll see that this is going to be a combination reaction where K and F, they're going to combine to form KF. Now the reason it's not KF2 is that if we look at our charges of each of these, we have K, and remember on your periodic table you can find your charge, it's a +1 charge, and then we have F, and it has a -1 charge. Since these charges are balanced, that means we don't need any numbers down here when we write them as a molecule together. So that's why it's not going to be our KF2 over here. It's just going to be KF. So then our second thing is to try to balance this equation. So we notice that we have 1K and 1K, so that's balanced. Then you'll notice we have 2 F's. So on this side, we have to add a 2 in front so that we have 2 F's on the other side. Alright, so you see 2 F's here, this is 2 F's here. Now, like when we put a 2 in front, the 2 goes for the F, but also it goes for the K. It's like distributing in math. It goes for the F and for the K. So we have 2 F's and 2 K's. On this side we have 2 F's, but we only have 1 K, so we need to write our 2 in front of our K. And that's how you'd balance this. So those are the kinds of things I'd be expecting you to do on your test. Now we're going to work through some more practice problems. They get harder and harder as we go. So keep watching. Don't just quit and go try the homework. I'd keep watching. So here we have one product, and we see it's going to split into 2 different products. So in your head, maybe be thinking about what 2 products would this split into. Alright, hopefully you were thinking H and O. Now, you'll notice that here with this F2, we had a 2 down here. That's because certain molecules are diatomic molecules. Here's the list of diatomic molecules, and that means when they're by themselves, they have a 2 by them. They come in a pair. So F is an example. We also see that H is an example, and O is an example. So whenever you're predicting products and you put an H or an O or an N or F or Cl, Br, I, if you ever put any of those in your equation, you need to remember a 2 by it. So on your test, you're allowed to use your own periodic table. So I might write on your periodic table the list of your diatomic molecules so that you don't need to remember them, and then you can have it in your brain when you take the test. That's how you would write that. Alright, so now we're going to just balance really fast. We have 2 H's, 2 H's, that's good. We have 1 O, but we have 2 O's on this side. Your side over here, you got 2 O's. So we need to make sure we get 2 O's on this side by adding a 2 in front. Remember, this 2 goes for our O. It also goes for our H. So we're going to have 2 times 2, so we're going to have 4 H's on this side. So that means we need to change this other side to a 2 in front so that we have 4 H's on this other side. Alright, you'll notice that I'm doing lots of this kind of balancing in my head. That's what I would be doing if I were you now. Trying to do a little bit more in my head, then you don't have to write as much down below. You're still welcome to write a lot below if you like, but if you like this way where you just kind of think about it in your head and then maybe double check your work when you're done, that works for me. Alright, this next one down here, we have an Al by itself and an HCl. So we have something by itself, and it's going to switch places with another thing to, this one is going to now go with the Cl, and the H is going to be by itself. They're going to switch places. So you can tell when you have just one thing by itself that it's going to switch with something in your equation and kick it out. So we'll have an H. Oh, let me get my green going. Sorry. So we're going to have an H over here. Now remember, H is diatomic, so you can put a 2 there, to know that. And then we're going to have an AL, CL. Now to know if we need any little, we call them subscripts, any little numbers down here, like we need the 2 for the H. To know for these, just like with this KF, we need to look at these ones' charges and then decide. So we have AL, it's a +3, and we have CL, and it's a -1. So those ones don't balance. So what we have to do is we have to bring the 1 for the AL and the 3 for the CL. Remember, swap and drop? So your AL is going to get 1, your CL is going to get a 3. So now let's see if we're balanced. So we have AL is 1, AL is 1, that's good. We have H here and H here. So what we could do is we could put in a 2 right here. But then we'll notice that your 2 for your H is good, but your 2 for your CL isn't good because we have to get it to match 3. So the 2 isn't going to work. So we can think of another number. You could try 4, see if that works, 5, see if that works. I'm just going to try 6 because I know that I need to get something with a 2 and a 3 to match up. So I'm just going to put a 6 in here. And then I know my H, I can put a 3 to get 6. And then just how the 6 goes with the H, it also goes with the CL. So I know I need to put a 2 here to get my CL to be 6. And my 2 also goes with my AL, so I need to put a 2 in front of my AL. All right, this is the last one. It's the hardest one that you'll see on your test, okay? So this one, you'll notice that it is a double replacement. We have something that has 2 different elements making up the molecule, another thing that has 2 different elements making up the molecule. You also notice we have a polyatomic ion in here. Maybe I'll underline that for you to be able to see. Polyatomic ion in here that's going to stay stuck together. So for this one, they're going to switch partners. So I'm going to have this AG and the CA switch. So I'm going to have CaBrO3, and then I'm going to have AgCl. Now again, we need to see if we need any little numbers down here. So in order to do that, we have to look at their charges and see if they balance. So we have a Ca, and it's a +2 charge, and we have a BrO3, and it's actually a -1 charge. Now you can find a list of these polyatomic ions in the help and support section at the top of Canvas, all right? So you can find a list of these to find out what charge they have. Now we'll notice these charges don't balance, so we need to make sure that we swap and drop them. So the 1 goes with your Ca, the 2 goes with your BrO3. So we need to make sure we put this BrO3 in parentheses and put the 2 outside of it. All right, so now what we're going to do is we're going to look at this AgCl. So for the AgCl, we'll look at those different charges and we'll see we have Ag and Cl. So Cl is a -1, but Ag is actually one that is a transition metal. Remember the ones where we used to put Roman numerals to tell us the charges in our thing? Like we'd write something like this, like iron, and we write like 3 or whatever, and the 3 told us the charge. Ag is one of those things where we need to know what the charge is. We don't know that from our periodic table. So in order to do that, I suggest you go back to this AgBrO3. So you have Ag, and we don't know the charge, and you have BrO3, and we know that's a -1 charge. So what charge then is our Ag? All right, you'll notice that since they are balanced here, this charge must be a +1 so that they'll be balanced. So this will be a +1. So we know over here that Ag is still going to be +1 when it's with that Cl. So those are going to balance out that way. All right. So then for this one, we can go through, we can try to balance it out. Again, we can do this pretty quick. So we see our Ag on this side is 1, Ag on this side is 1, perfect. Our BrO3 here is left blank. Our BrO3 here is a 2. So we need this one to be a 2. Right now it's just a 1. So we need to put a 2 in front here. All right, we have our Ca is a 1, Ca is a 1, Cl2 is a, or Cl is a 2. So this Cl also needs to be 2 over here. And then you can double check to make sure our Ags now are a 2 and a 2 on this side. BrO3 is a 2 and a 2 here. Ca is a 1, Ca is a 1, Cl is a 2, Cl is a 2. All right, like I said, that will probably be the most confusing thing. If you still need help on this, please let me know. I can send you a personal video. I can answer questions over Messenger. I know it's a little bit tricky, But you are going to be expected to be able to predict these products and balance an equation. Good luck with your homework.